Hello everyone. Welcome to this session. In this session, we are going to learn how you can modernize your Microsoft applications on AWS. My name is Srimanta Tanaikar, and I'm a partner solution architect here at Amazon Web Services, focusing around Microsoft technologies. So what's the agenda for today? I will walk you through why you should modernize Microsoft applications and why you should do it on AWS. Then I will walk you through your modernization journey where you move from your on-premise environment to the cloud and then start refactoring your applications. I will touch upon certain areas like containerization and what kind of radical changes that you can make to your applications to make them more cloud native. And finally, I will introduce you to some programs, fundings, and boot camps available for you to start your modernization journey. A very interesting question a lot of our customers sometimes ask is why modernize Microsoft applications? So there are multiple reasons. We all know that Microsoft products or any software application has some kind of a life cycle. So after this life cycle, it comes to something called end of life. And after that, the software will no longer be supported and you will not receive the security patches, the updates from Microsoft. And it becomes super expensive to maintain these legacy applications. And there are some other dynamics. For example, you may find it difficult to find the talent in the market who can operate on these legacy applications. You will find issues around the tooling and utilities. For example, your old virus scanner may not receive the latest virus updates. And also, there are some issues around browser compatibility. I have seen a lot of enterprise customers running multiple versions of the browser because the new browsers don't support legacy applications. And you need to sometimes spend a lot of money around provisioning some environments like Citrix environments that can run these multiple versions of the browsers. And also you can face some issues around integration. For example, the legacy authentication system that your application uses may not be compatible with the new authentication that your new application is using. So your new projects get blocked because of the issues that you find in all projects. So the true cost of not modernizing your application is not only around application maintenance, but also around lost time, lost productivity of your new applications. So you need to find some ways to break this vicious cycle. So there may be some multiple reasons that you decide to move to the cloud or modernize your applications. So it could be around cost pillar. Maybe your warranty is expiring for your hardware and you want to update them. So that may be the reason that you are moving into the cloud. Maybe you want to increase your resource efficiency, where, for example, earlier your administrators may be managing 100 applications. And with the new tooling, you want to let them manage 200 applications. Maybe you are looking at operation resilience. For example, on your on-premise environments, creating a highly available SQL Server cluster may be expensive. But in the cloud, provisioning all these highly available clusters is super easy and given for granted. And that may be something that you are driving. So it's not only the cost pillar that you are driving, maybe some other dynamics that you want to try to drive with modernization journey. The other thing is to use this the commoditized innovation that we are doing on AWS. We innovate on behalf of our customers. For example, last year alone, we released about 4,400 plus new services and features. And these are the new features that you can use and start innovating. For example, instead of you trying to come up with the next generation artificial intelligence algorithm, let use the API endpoints that we provide and then innovate faster. So instead of taking 6 months or 1 year to come up with this latest AI algorithm, just try the API and then come up with your solution within 1 or 2 days. So when you look at your application portfolio, there are some applications that make sense to modernize. So you need to do the cost-benefit analysis to understand which applications that you are going to modernize and which applications are not. So when you do that analysis, you may come up with some solutions. For example, if your application is, let's say, 1 year old, right? Maybe you decide to keep it as it is, right? You're not going to make any modification. Maybe you have some application that needs is too old and doesn't add any business benefits. Maybe you decide to completely terminate that application or retire that application. You're going to shut it down and archive the data. So that's where the retire piece comes into picture. So in this session, I'm going to spend more time discussing around the refactoring piece and also the rehosting phase. For example, initially you may decide to move away from your on-premise data center. You do a lift and shift kind of migration, and then gradually you may start refactoring your application, making it more cloud native. You may also decide to completely throw away your application and then purchase a new one. For example, if you have a CRM application, so instead of using your on-premise application, you may decide to go for Salesforce kind of application. So a very common question that is asked is, why run Microsoft applications on AWS? The answer is very simple. If you look at the IDC report that is recently released and look at the worldwide Windows public cloud market share, the market share of AWS is more than all the other cloud service providers combined. And this is just for Windows. So if you take Linux, it's even bigger. So with that, we get like the scale of operation. We innovate on this space a lot. And these are the benefits of running Microsoft workloads on AWS. 95% of our roadmap is driven by customer use stories. There's a large number of enterprise customers that is running on AWS. So which means the problems that these customers face, we have already given solutions for them. There's a large number of startup companies running on AWS. So these are the next disruptors in your industry. So you need to have the same tooling and the same infrastructure in place to benefit from the innovation that we are doing. And there are a lot of public sector customers. So if you are a security and compliance conscious customer, we may have already gone through these the problems that you face with these public sector customers. And there's a large and the broadest ecosystem of partner ecosystem in AWS. Last year alone, we added over 10,000 partners into our ecosystem. It's not only about adding partners into the ecosystem, it's about grooming them, making sure that they go through the certification process, making sure that they have the right competencies and auditing them, so that you have the best in the class partners to help you in your migration journey, in your modernization journey. Especially like if you are doing like large scale modernization or migration, partners are super important because sometimes you cannot do it all by yourself. And more importantly, there's the broadest ecosystem of ISV and SaaS providers. So if you look at, for example, Adobe Creative Cloud, Atlassian, companies like the Autodesk run on AWS. If you look at our marketplace, there are over 4,000 listings. So if you want to provision your SharePoint farm, if you want to provision Microsoft Dynamics, you can easily provision these solutions with few clicks. And most importantly, like we have been running Windows workloads over 10 years, and there's no compression algorithm for experience. Over the last 3 years, there was about 400% growth in enterprise adaptation of EC2 Windows servers on AWS. Especially for your business critical application, high availability and reliability is super important. If you plan to run your Exchange, your Dynamics, your SharePoint farm, your .NET applications, reliability is super important. And if you compare our reliability to, for example, to Azure, we are far ahead than any other cloud service provider. And 2018 numbers, these are all recent report, it's even better. So if you look at the downtime for our compute and storage, that's very small compared to what our competitors are. And especially for APAC customers, the downtime for compute and storage, which runs bulk of the Microsoft workloads, we are doing really good. Little known fact about AWS is that we are a gold certified Microsoft partner, and there's a very strong relationship between Microsoft and AWS. We innovate, both teams innovate on behalf of our customer. For example, when our customer says we would like to program for AWS using .NET, we created the .NET SDK. When our customer says we already have invested our money on some on-premise licenses, we would like to bring them into AWS, we created solutions like dedicated host. When our customer says we would like to have managed Active Directory, we create a directory service. When our customer says we would like to manage large fleet of Windows servers in a single pane of glass, we created EC2 System Manager. For example, we released the support for .NET Core 2.0 on our Lambda function, which is our serverless technology, faster than even Azure functions. And the two engineering teams work very collaboratively, bring these great technologies to our customers. And also you have Premier support directly from AWS. So if you have any issues around Microsoft technologies, you can directly contact AWS. And we have escalation paths directly to Microsoft, and there are dedicated engineers to assist us on the process. So I'll now walk you through the migration and modernization journey, where you first move from your on-premise environment to the cloud. So the first thing is to put a business case. So for example, what you are maybe trying to do is you may have some on-premise, some bunch of servers or some applications that you are running. So your driver may be to reduce that cost. So you may put a business case here. This is how much it costs to my on-premise environment, and this is how much it costs me on the cloud. To assist you on that, you can do with Excel sheets, or you can use some partner tools like TSO Logic. For example, this TSO Logic can analyze your existing infrastructure utilization and then suggest the right size instances on AWS. You can input data around your license portfolio, and it can better optimize your existing license portfolio on AWS and then assist you in that business process creation. So you may try to drive cost savings. Maybe you are trying to drive some user satisfaction. Maybe the performance of your application is not good and you want to increase that being on the cloud. Maybe you try to get the agility of that you want. That may be some thing that you are trying to drive with this modernization journey. So once you create this business case, there's a lot of processes in place to assist you on that. We have a program called Migration Acceleration Program that can assist you in finding the gaps you may have in your organization. For example, when you try to modernize your application or migrate to the cloud, you may have some gaps around your people where they need to be reskilled. So we can do, for example, some workshops, some training, send them through some certification to bring them up to standard. Maybe you have some gaps around your compliance, or also your governance, where you need to do certain documentation. So what this migration acceleration program assists you is finding those gaps and put you a proper plan, some sprints, some work items, so that you can fill those gaps and then move to the cloud with less risk. So our partner ecosystem can help you on that. Our solution architects are in there to help you on that migration journey. And also you can engage our professional service team who can assist you on this. We have done thousands of these executions to like a lot of customers, and we have a very mature ecosystem to execute that. So you are now on your on-premise environment. So you may decide to move into the cloud. AWS is the only cloud service provider that still supports legacy 32-bit operating systems, which means that you can lift and shift your old legacy applications like Windows 2003 machines running 32-bit operating system directly into AWS. So you can use tools like Server Migration Service or our partner solution like Cloud Endure that can right-click and do live migration into AWS. So during this process, so for example, if you try to do this one in another cloud service provider, you first need to upgrade your operating system to 64-bit, which means that at the initial stage of the project, you are incurring a very high cost, and also it's too risky. So now let's go into the refactoring phase. So for example, I'll first give you some introduction into some low-hanging fruits that you can capture and then shows the value of the cloud. And then we'll go into more advanced topics. So you have this simple system that you moved into the cloud, right? So your first priority may be to upgrade this operating system. So if you try to do it on premise environment, you need to find some hardware to do the testing, and also they will take some time to provision. But on the cloud, you can easily spin up environments. So you may create another environment and then start doing the testing. So for example, you can upgrade your operating system from 2003 into 2016. And they may probably do, you can do a file copy, MSI installation to get your old application into the new application, new operating system. Maybe you may have some issues around legacy application. For example, if you have a legacy Windows 2003 application and it expects your operating system to have an API called getFile, and that getFile is not available on the new operating system, you may face some issues. But our partner solutions like CloudHouse Containers can assist you to map these old APIs into the new platform. So please feel to engage our account teams and our partner team to assist on this kind of complex migrations. For the SQL Server, you may decide to do a database backup and restore, or you can do replication. And to go into a bit more into cloud native kind of design, initially you may decide to have something like your backups on an S3. For your batch application, so instead of running your batch application 24/7, you may decide to use spot instance where you bid for unused capacity on AWS and you get deep discount to run your EC2 instances. So instead of running your, for example, your batch application for 24/7, you may run your batch application for 1 hour. And for that 1 hour, you bid some capacity on AWS and get a very deep discount on the spot instances. So you can see that we are gradually moving towards a cloud native architecture, and you may save some cost during that process. So we still manage our SQL Server by ourselves. What can we do about it? You can move from this manage the SQL Server that you manage to a managed instance where AWS manage the SQL Server for you. So maybe you don't want to do the patching and maintenance of this instance. It takes database administrators valuable time. For example, you can repurpose the valuable time of database administrator to spend more on, for example, optimizing the queries, creating SSAS cubes, or creating reports. Instead of spending their time on mundane tasks like updating the operating system, updating the database instance, taking backups. So these are the valuable time that you can spend on more business value-added tasks. Application change is very simple. You may probably change the connection string of this web application to point into the managed instance. So there are a lot of other managed instances available, services available. For example, you can run Oracle SQL database as a managed instance. If you want to have a managed Active Directory, you have AWS Directory Service. And for example, if you want to run managed IIS kind of environment, you have Elastic Beanstalk. And some of these services are actually free. For example, Elastic Beanstalk itself is free. For example, if you have two EC2 instances that you manage by yourself, so it may cost us an amount, but letting Elastic Beanstalk to manage is going to cost you the same amount. The beauty of Elastic Beanstalk, for example, is that you can do some cool things like provisioning a new IIS or application environment is just a mouse click. If you want to swap your URLs from pre-production to the production, it's just a mouse click away. If you want to revert back an application that failed to deploy, it's just mouse clicks away. So there are many other managed services that you can use and then stop doing this undifferentiated heavy lifting that does not add any business value. So we have this simple architecture right now. So when your business grows, maybe high availability becomes something very important. So you may decide to go for highly available architecture. So you may use our availability zones to deploy that. An availability zone is, so within an availability zone, you have multiple data centers. Two availability zones are in two geographically dispersed locations with miles apart. Usually they are fed by two different power suppliers, and they are in two different floodplains, which means that if something happens for one availability zone, if your application is running on the other availability zone, your application will still continue to function. So back in the days, like on-premise environments, this kind of a setup is super expensive. But in the cloud, you can implement them very cost effectively. So you may decide to run your web application as two web applications, right, in two availability zones. So you may ask now, hey, Sri, will it increase my cost? Now, instead of running one web application here, I'm running two web applications here. May not be so. For example, instead of running, so this may be a large instance. So you can have half that instance size in two availability zone and put it in behind the load balancer. So you are not doubling your cost. The cost may increase marginally, but you are not doubling the cost. But in return, you get the high resilience. So if your application is stateless and it doesn't have any shared session, it may be easy to implement this. But if you have any shared session, you may decide to have something like Amazon Elastic Cache that you can keep those information. For the database instance, you may decide to use a single SQL Server instance. That's perfectly fine. So you may ask, hey, Sri, now this is a single point of failure. Well, what's the value of this architecture in the first place? The answer is that you can do role-in deployment. For example, when you try to upgrade one web application, the other one will be available. And also, when you try to design this architecture, you need to ask questions around what's my recovery time objective? What's my recovery point objective? And I have seen some customers with a recovery time objective of 4 days. So this kind of a solution may probably work fine. But if your recovery time objective is, let's say, 5 minutes, then you need to have another instance running on another availability zone. So you need to decide these architectures based on your business needs and try to save some cost. Don't try to over-engineer the solution. For the batch application, you can run it in a single availability zone. Alternatively, you can decide to put it in an auto-scaling group and set the desired count of that auto-scaling group into 1. So when this batch application runs, and let's say it fails halfway through, the other batch application will start. So you need to do a bit of code change into this batch application to do some kind of thing, like, for example, when the batch application 2 starts, if it realizes that the first application has failed loading the data halfway through, it can flush that data and then reload again. So there are a few bit of code changes that you need to do when you are moving to more cloud-native architecture. So an obvious question now is what kind of language and platforms are supported on AWS. Pretty much every imaginable language, famous languages are supported, especially if you are a Microsoft shop developing on .NET. All our APIs are exposed on .NET Framework. All our APIs are exposed on PowerShell and command line. And there's great Visual Studio tooling support available for you. For example, all our .NET libraries are released as NuGet packages, so you can easily integrate with your .NET applications. So what are the other tweaks you can do? So we have this simple web application. You may decide to offload the images, JavaScript, videos into an S3 bucket, which is our object storage. So you reduce the workload on web application, you put them into S3, and you get better performance, and sometimes for lower cost. You may decide to go for the CloudFront, our content delivery network, to distribute your content across multiple geographies. The beauty of these solutions is that, for example, you decide, hey, the CloudFront I don't like, I just want to try it. I'm just testing it. That's perfectly fine. After the testing, just throw it away, because these are pay-as-you-go license. So this is not like your on-premise environment where you spend a lot of money on provisioning, right? So the risk of failing, the cost of failing on AWS is very minimal, right? So if you don't like it, you can keep using the traditional way. So another reason for modernizing your application is around improving the developer productivity. You need to release software faster. You need to get your new features quickly. So our business is not going to wait 2 months or 2 weeks to get your new sets of features out. So bookmark this or take a screenshot of these URLs where I explain how you can easily integrate AWS technologies with like Microsoft technologies, like release software. So you may have some like build systems like Microsoft Team Foundation Server, Team City, Jenkins, and all of these systems allows you to add build steps, which you can easily integrate with PowerShell and command line. Because our APIs are exposed in PowerShell and command line, you can easily integrate with all our developer tools. For example, if you want to release a software when the developer commits some changes into the source control system, you can use a technology like code deploy to push those changes into the production environment or testing environment. So if these environments are managed by something like Elastic Beanstalk, you can use that Elastic Beanstalk APIs exposed in PowerShell to release your software. So developer productivity is super important when you try to be more innovative, more agile in your application deployments. AWS CloudFormation is another cool thing. Remember the days it took ages to deploy SharePoint farms. It took ages to deploy your Active Directory, your SQL Server stack. But with the CloudFormation, you can now code infrastructure as code and keep a version instance of your infrastructure. So if your developer wants to spin up some environment similar to, let's say, production environment, you can simply do a few mouse click and then provision that environment instead of waiting weeks. And when the developer has finished testing, you can just shut it down. So that gives you this on-click, on-demand provisioning of environments becomes super easy with this kind of infrastructure as code technologies. So let's go into the containerization piece. Containerization is a hot topic. And why is it a hot topic? There are multiple reasons for that. Containers are lightweight. They are easy to manage at scale, especially when you have thousands of containers. You have tooling support available for you to do that. And more importantly, they use resources better. And I'll come to that piece later. And there's a huge paradigm shift around going for microservices. This presentation is not about microservices. There are pros and cons of going for microservices kind of design. But if you look at the advantages, they usually outweigh the disadvantages. So microservices allows your team to innovate faster, release software faster, reduce the dependencies that one team has with another team, right? So your application that we discussed, we have been talking throughout this presentation, will change to microservices. So how it will change, how it will evolve. So your IIS-based application that you ran, your ASP.NET, MVC, or Web API will break down into small API endpoints. So the John's News team in Singapore will have their own API. Sarah's HR team in India will have their own API, right? So your monolithic application will break down into multiple small services. So one application now all of a sudden becomes about 10 applications, or 10 applications becomes 100 applications, right? But the good thing here is that the John's team now can release their software independently from Kate's team. He can choose the technology he likes. For example, the data sets, the one big SQL Server instance that you used to have will break down into small data sets. HR will have its own data sets, finance will have its own data set. The beauty here is that, for example, if the travel team decide that they want to have a high performance database, they can choose the technology that they like. Maybe they decide to go for NoSQL kind of a technology. Maybe Sarah's team decided to go for file system instead of relational databases. And ETL jobs that used to run bulk of this loading in one console application may break down into small extract, transformation, load ETL jobs. So the teams can now work independently, but in effect, you have increased the number of applications. So how can you manage that complexity is the next question. So I'll go into some differences on the virtual machines and containers first. So both needs to have some kind of a server to run. Both needs to have some kind of a host operating system. And both needs to have some kind of a hypervisor to run. In the case of virtual machines, you spin up these virtual machines on top of the hypervisor. The challenge here is that the shareable resources are not properly shared. For example, if this operating system is Windows 2008, if both operating systems are Windows 2008, 99% of their content is going to be the same. But you are not sharing that content, which means that you are going to waste your storage. And on top of that, these operating systems have their own background things like the printer job, the virus scanner, the firewall, right? And they take memory and CPU that the applications can use. So in the case of containers, you have this concept called immutable images, right? So the immutable image is something that can be shared across the multiple containers. So container 1 to 4 share one image, and container 5 to 6 share another image. But the beauty here is that the container 1 is completely isolated from container 4. So the application, the address space, the memory, everything is isolated. So because of this efficient usage of resources, instead of running 2 applications, now you can run 6 applications on the containers. So that allows you to increase your application packet density in a given hardware. Now, your traditional environment, like for example, if you have an IIS web application, very likely this would look like this, because you are going to run multiple applications on a given server. It will end up in its own containers. So HR team will release their own container, the finance team will release their own container, travel team will release their own container, right? So if you are a developer who depends on all of these containers, you can easily spin up them on your development machine to testing, right? So the beauty here is that the HR team now can release all the HR related applications along with the dependencies in one container or like multiple containers. So running a single container is super easy. The challenge comes when you try to run hundreds or even thousands of containers. You need to think about how I'm going to schedule them, how I'm going to find the right host to run them, how can I define constraints that these containers has to adhere. And that's where Amazon Elastic Container Registry and Elastic Container Service comes into picture. So Elastic Container Registry is just another container repository. It's like Docker Hub. The only difference is it's tightly integrated into Amazon Identity and Access Management. So you can say, for example, hey, these are my production images and they are only allowed to run on my production servers. Elastic Container Service is yet another container orchestration engine. We have other orchestration engines like Amazon Kubernetes, but it's just another container orchestration engine that allows you to orchestrate containers. So how it works is that you have this cluster of compute and network resources, and you create something called a task, right? And on this task, you define what set of containers you want to run. Here, I want to run SQL Server, and I want to run web service. You define the constraint that needs to adhere to. So, for example, you can say, hey, the HR application should run on the same host the finance application is running. And you define what's the memory and CPU demands. The orchestration engine can then easily place these containers across multiple hosts. For example, if you decided to use bin packing kind of an algorithm, it can fill one host before going into the other one. If you use some kind of a balance spread kind of deployment, it can place containers evenly across multiple hosts. You can also define your own custom algorithms. You can define your own constraints. So what will happen is that your application now will like broken down to small services and run on this cluster. The good thing here is that if HR application is not using resources, those resources are available for marketing application. So you can balance these resources well and also increase the utilization of your resources more than going for virtual machines. So what are the other complete radical changes that you can make to your applications? We have been running our applications on your on-premise environment on physical servers for a long time. And then came the virtualization, where we try to increase the application packet density, increase the data center efficiency. Then we moved into the cloud. We got this on-demand pricing. We don't need to do CapEx expenditures. We can go for operational efficiency being on the cloud. But you still manage the servers, right? So the next shift in this paradigm shift is going serverless, which means that you don't manage any of the servers. You focus only on your business logic, your programming piece, and then hand over all these undifferentiated heavy lifting into AWS. So which means that you don't focus around, like for example, how I'm going to patch my operating system, how I'm going to maintain it. You are not focusing around scalability because the Lambda, which is our serverless technology, allows you to scale automatically. You're not worried about how I'm going to make them highly available because our serverless technology like AWS Lambda is highly available by default. So what serverless means is that you ignore you completely focus on your business activities and forget about these undifferentiated things like server management. You get the flexibility of scaling, and also your solution is highly available, and you don't pay for idle capacity. So if you look at any server environment, sometimes the server utilization is 5% or 10%, and it's difficult, especially for like a solution like SQL Server, to scale it automatically, scale vertically, right? So how this works is that you have this event-driven approach. So when a door is open, when your burglar alarm fires, when some issue happens in your factory, or when somebody clicks on your website, or when somebody tries to log in using their mobile application, events get fired. So you can hook multiple events, and once these events get fired, the Lambda functions get executed on a pool of compute and memory resources available for you. So you may get, like, say, 10 requests. It automatically scales. During the peak time, you may get million requests. So you can easily execute millions of those functions automatically. So it automatically scales. So if you have a web application, or if you have a mobile application, and some people start taking pictures of a special event and they start uploading images, so that triggers event and it automatically scales, and it can handle that millions of requests coming. And you only pay for the usage that you are using this, right? So there's a mature portfolio of serverless technologies. AWS Lambda is the compute engine. If you want to integrate it with the API gateway, like for example, if you want to implement things like throttling, if you want to apply security, there are other AWS portfolio technologies available for you to easily integrate. For example, if you want to do distributed debugging, right? So when you have a distributed application, you need to have tools like AWS X-Ray to get full visibility into your application API endpoints. .NET Core is the future. .NET Core is fast, they are cross-platform, lightweight, which means they take less resources, and it has smaller footprint. I used to be a .NET full framework developer, and I was a fan of that. I'm super into .NET full framework development, and I was promoting that. And later in my journey, I was having a lot of conversation with the customers, and I realized how many of them are using it. So I completely changed myself and then start using .NET Core. There are a lot of, for example, I got feedback from banking customers, enterprise customers using .NET, because it makes sense. If you have a platform which is faster, better, and more integrated than any other platform, well, of course, it's the right engineering decisions to use it. And besides all, there's a great community behind it. So if you look at Microsoft, for example, they are super active on .NET Core. They released version 1 somewhere in 2016, and also the 2018 they released the version 2, and they announced .NET Core with some cool features somewhere in May 2018 with Microsoft Build Debate. And they are super active on this project, which is great. And also it's an open source project, so you can get more security, less security issues in this kind of a platform. So what if you marry serverless and .NET Core? And it's going to be beautiful. For example, you may now start writing your applications in your business logic in some kind of a .NET Core DLL. And you can use Lambda as the runtime engine. So your mobile application, your browser will interact with some kind of an API gateway endpoint. And this endpoint will invoke a Lambda function to run your business logic. You may decide, hey, am I getting locked into Lambda because of this? The answer is no. If you decide, hey, I don't want any of these AWS Lambda or API gateway, and you decide you want to go for your on-premise solution with IIS, you can still do that. You can run your .NET Core application, your business logic, and you can host it on your IIS. So we don't want you to log in into any of our technologies, and that's us being very customer obsessed and helping you in your journey. You can, for example, if you have a console application, you can still use the same business logic that you used to use. And also there is a huge paradigm shift around offloading most of the processing into the client side. Your mobile device, the browsers, the latest browsers you have are now very capable. They have a lot of compute, they have a lot of memory. So let's offload most of these tasks to the client side. So if you go along that path, so you don't need to have these web server technologies, right? So we used to do this kind of design where your mobile application, your browser talks to a web server, and then the web server, for example, invoke a database query to query for data, and data come to the web server and it returns the data back. But with this direct service invocation capabilities, you can directly invoke the databases, the storage. So you can offload most of this processing the web servers did to the client side. The beauty here is that you reduce your cost of operation. So for example, if you want to invoke DynamoDB from your mobile application or from your web browser, you can easily do that. Of course, you can first authenticate against, for example, AWS identity and access management technologies like Cognito, or you can authenticate against Google Authenticate Provider. And once you have the credentials, you can invoke these services. The object storage S3 is also not just a storage. You can do some smart queries. For example, you can execute queries like SQL queries on S3. So you can say, hey, give me all the files related to last financial year, right? So because the cost of operating on this kind of environments, S3 is much, much cheaper than operating a SQL server or relational database, you save cost. And also you offload the load on these servers, so you can select smaller instance sizes. So what will happen in the future is that these web applications will be replaced by technologies like AWS Lambda, API Gateway, or S3 kind of buckets, right? And your relational databases may very likely be replaced with technologies like NoSQL databases, AWS Lambda, or S3. Maybe this one big SQL Server database you used to have may be split into small different technologies that you think is suitable for your specific applications. Batch loading applications, if it is a very complex one, you may still keep to run it on EC2 instances, or if it is like a small, like a console kind of application, you will probably replace it with some AWS Lambda kind of technologies. So take a screenshot of this. There are some examples I have given where you can run ASP.NET kind of applications on Lambda technologies. So this is the URL over here. So you also start challenging yourself around your designs. So you can ask, do I really need a relational database in the first place? Can I just use a JSON file or XML file? For example, instead of keeping this the trip information on a database, can I put it into a JSON file and keep it on S3, right? So for example, you can also start thinking, can I expose some of these information as an API? So for example, if you have a multiple application that uses cities, you can expose it as a OData endpoint with some query capabilities. So the beauty here is that, for example, you can cache that city information, so multiple application can get that city information faster. So start challenging yourself on the way that you used to design, because relational database was designed for at an era where storage is expensive, but now it's the compute which is expensive, right? So you need to evolve your architecture accordingly. You also start to think, am I selecting the technology right? For example, there may be some skewness in your table. So you may get challenges here. Our database is 10 terabyte. Dive deep, select which tables are big. Maybe you have one or two tables which are frequently accessed and big. Maybe you have one big audit table that nobody uses. You just keep audit data there. Start challenging what database features you are actually using. For example, you may have some commercial vendors pushing solutions saying that, oh, this is a cool technology. Challenge yourself, do you really need that? For example, if you have a special data type to keep longitude and latitude, Why don't you keep two floating numbers and keep it in two columns? So start asking these questions and dive deep. So for example, if you are moving away from Oracle or SQL kind of a database, and if you want to re-platform your applications, we have tools like AWS schema conversion tool to analyze them. It can convert the schemas automatically, or it can give you an idea around how complex migration from a commercial product like SQL Server to more open source kind of technologies like Amazon Aura. So you can do like a complete moon landing kind of changes. That's one approach that has its own pros and cons. Alternatively, you can take some baby steps where you gradually move your architecture into more cloud native kind of a design. So they both have pros and cons. You sometimes need to do moon landing to change your application because the traditional way of doing things doesn't work. So you need to know that there are special ways to operate on this kind of environment. So especially in the cloud, the environments automatically scales. The web server that used to run for 24/7 is going to may run only for 5 minutes. So you need to adapt to your architecture accordingly. So what kind of changes you can make? You can make changes into your login approach. So if you are already using your like Windows event logs, if you are using Windows performance counters, or if you track log files on your IIS website, the CloudWatch agent can read. CloudWatch agent is going to run on your EC2 Windows machines and can read this information and send it to a central location. So for some reason, if this application fails, your logs are available. You can use the CloudWatch.net API to directly write into the central location. So how can you keep data configuration and secrets in these highly distributed architectures? If you are using a container environment, the container host can keep this data. The container, when they start, these data volumes will get automatically mounted. So you can have container images without data and configuration, but when they start running, those data and configurations will get mounted. You can keep this shared data in S3 bucket or some kind of a DynamoDB or NoSQL kind of a database. Good old environment variables are still available. So you can keep your environment variables. Most of these managed platform, either container service, Elastic Beanstalk, they have their own environment variables, and you can access them in whatever the method that you prefer to access them, right? So I keep this my super secret password as environment variable, which is not the best approach. If you want to keep secrets, you have a simple system manager and then access them. So you define something like a scope. This is my contours or production password. You keep this encrypted secret. So once you define that, you can access them very easily. So for example, you define a policy saying that, hey, this policy allows accessing contours or production, anything under contours or production category. And you attach this policy to your instance, and all of a sudden this instance get access to the passwords under the scope. And after that, of course, you can access this secret using your PowerShell or .NET if you like. If you don't have access, you will get an exception as I've shown here. Scaling and service discovery is another important topic. So what will happen is that you are going to expose your API endpoints like this and with some URLs. And they may be behind some kind of an application load balancer or a DNS system like Route 53. So when your container starts, it's transparent for your API endpoint. Your application will continue to function. When containers are shut down and some are running, your APIs are still going to work fine. You can discover your application endpoints using these DNS entries. How can you handle failures and how can you handle failures in services? So for example, in this kind of a distributed architecture, you may have this, for example, Kate's application talking to Sarah's application talking to John's application, and you can have these multiple connections. And debugging this kind of application needs special tools, and that's why tools like AWS X-Ray come into picture. So it gives you a bird's eye view of what is happening. For example, if application C is slow, it can affect application A. But you can find all these latencies through AWS X-Ray. And also, how can you handle an error if application C fails? How can you handle it? how application B is going to behave. There are cool ways to do that. For example, if you read the microservices architecture, one way to do that one is to retry with exponential backoff. So which means that if you find an API endpoint failing, you can wait for 2 seconds and then try. If it keeps failing, you wait for 4 seconds and try. It still keeps failing, you wait for 8 seconds and try it. The idea here is that it doesn't make sense to keep invoking a service that is keep failing, right? So you wait so that you don't create extra overheads to this application. Maybe it's restarting, right? Maybe somebody put a patch into that, and in another few minutes it will be available. But if your application keeps failing, it doesn't make sense to keep waiting. So let's fail fast, and that's where the circuit breakers comes into picture. If everything fails, for example, if you keep failing for let's say 6 hours, just go into a static web page directly, and that's where the fallback plan comes into picture. So if you are like a .NET developer, there's a nice library to program for that. There's a library called .NET Poly that you can use to program for this kind of design. So what you learned today, you learned why you should modernize Microsoft applications, why run Microsoft applications on AWS. I walk you through the migration journey, how you can optimize your platform, the refactoring piece, and what kind of radical changes that you can make to your applications. There are a lot of programs available for you to accelerate your modernization journey, your migration journey. For example, a rapid migration program is where you can execute very quick proof of concepts to test the cloud, to try your new applications. You can engage our partners to execute these POCs. Feel free to contact our AWS account team or partner network to get support around this. Training for Windows is also available, which means that if you are doing some migration, there are funding available for you to assist in your migration journey. There are a lot of workshops, programs available. For example, migration acceleration program can be used to accelerate your cloud adaptation. So if you want to find gaps in your organization, if you are not sure how to do a proper total cost of ownership analysis, the migration acceleration program can assist you. So engage us, engage our partner ecosystem and account team to help you on this journey. There's a boot camps available for you. Take a screenshot of this and register for this. We are executing this across APAC in Australia, New Zealand, Singapore, Malaysia, India, pretty much all the countries. And also we execute this bootcamp for individual customers with real need and use cases. So if you have any need of learning containers or how to execute in a containerized environment, tell us your use cases, and we are very happy to help you on this. So we don't charge on this Ninja Bootcamps. It's a hands-on labs where you will full day going through intense container training, learning about microservices, learning about CI/CD or continuous delivery pipelines. So take a screenshot of this and then register yourself and express your interest, and we will plan the bootcamps for you. There's AWS training and certifications available for you. So if you want to get certified and learn about AWS, feel free to explore our training site. There's a lot of resources available for you. And getting AWS certification is one of the best way that you can learn AWS and mature in cloud technologies. Make sure that you fill the survey form. It's super important. We need your feedback. We need your input to improve this kind of webinars and sessions. So tell us what you learn about this. Tell us your use cases. Tell us how we can improve this one, right? So make sure that you complete the survey form at the end. So that's it, friends. So this is the Ninja Bootcamp, the URL. So if you are interested in, feel free to tell us which countries or which cities you would like to execute it, your use cases, and we are happy to help you on that. If you have any questions, I will try to answer a few over here. So yeah, so one question that is asked is, can I run .NET full framework applications on containers? The answer is yes. You can do that. Another question is, can I bring my SQL Server license into AWS? The answer is again yes. So if you have like existing license portfolio that you already have, you are free to bring it into AWS. There are a lot of ways to do that. You can either use license included AWS instance to run your applications. Alternatively, if you already have some applications that you have invested and you have some licenses, you can still bring them to AWS. There is a nice frequently asked questions around Windows licensing on AWS. So if you Google Microsoft AWS FAQ, you will find really good answers around how you can move your licenses, how you can move your SQL Server footprint into AWS. So thank you all for your time today. It's really excited to go through this kind of content, and feel free to engage our account teams and our partner ecosystem to go through your modernization journey and use our proven methods to like migration acceleration program to accelerate your cloud adaptation.